Hi. This is the summary of all those transformations and the graphing techniques that we learned in section 3.5. So I want to go back and clarify some things on this sheet and tell you that you may use this on your test if you want. I am okay with that. So make a note. If you want to, fine. If you don't, fine. So first thing I'm going to do is I'm going to go through here and I'm going to put the order that we should do these things in. Then I'm going to go over here and give you an example of each one so you know what all this stuff over here is actually saying. So remember, for order, we need to be following the order of operations for how we evaluate it. So essentially, if we would start with our horizontal stretch or compression, then we would do any reflections about the y-axis. Next, we would do horizontal shifts. Then we would do vertical stretches or compressing. Then reflecting about the x-axis, and the very last thing we want to do is our vertical shifts. So let's see what this works, how this works. So let's say for the vertical shift, I'm just going to give you an example. So if our parent function is x squared, then the transformation would be f of x plus, say 3, which means we would really have x squared plus 3. If we're doing a vertical shift down, it would look like subtract a number. So we would have x squared minus 2 in this case. And I'm doing these out of order. I'm just giving you examples of what they look like with numbers, because I know a lot of you get messed up by all those variables. Okay, let's look at the horizontal shifts. For the horizontal shifts, if we have f of x equals x squared, if we're shifting to the left, we would do f of, say x plus 1. So that would be the quantity x plus 1 squared for our function. Shifting right is the same thing, but we're doing it inside. So we're evaluating f of x minus 4, and it's a negative because horizontal shifts are backwards from what we think, right? Okay, so we've got vertical shift examples, we've got horizontal shift examples. So vertical stretch. A vertical stretch looks like, if we start with f of x equals x squared, then a stretch would be like 2 times f of x, which in this case would be like 2x squared. A vertical compression of x squared is the same thing, but we use a number between 0 and 1. So a proper fraction when we multiply. Okay, so there's our vertical stretch and compression. Our horizontal stretch is multiplying by a proper fraction inside. So we would have f of x, f of, say, 1/2 x, which would equal the quantity 1/2 x squared. And then for a horizontal compression, it's the same thing, but we use a number bigger than 1. Okay, and then the reflection about the x-axis, if we have f of x equals x squared, the reflection is just to make that negative. Reflection about the x-axis. Reflection about the y-axis is we replace x with negative x. Okay, so there's examples of how all those work. Remember, if you have any questions, you can ask me about it during class. That actually, believe it or not, ends section 3.5. So we will pick up again with section 4.3.